For 30 years, Hubble's archive sat open. Astronomers used it. Students studied it. NASA published its images. Then an AI checked it again. In 2.5 days, it searched almost 100 million pieces. It found more than 1,300 strange objects. Hundreds had never appeared in scientific literature, not because Hubble missed them, because humans did. Some were warped by gravity. Some were galaxies in collision. Some had tails. Some looked like cosmic hamburgers. And some did not fit cleanly into any familiar category. The archive was not empty. It was unfinished.
Hubble has watched the sky since 1990. More than 3 decades of images, galaxies, nebulas, star clusters, deep, empty-looking fields. An archive is not just a storage room. It is a second sky, one made of files. Every image was stored. Every file was kept. Astronomers searched this archive constantly, but they searched for what they already knew how to find. Bright stars, familiar shapes, known patterns. Strange things could hide in plain sight. Small, faint, tucked into the corner of an old frame. Not because the data was missing, because nobody had looked at it that way.
Some of what the AI found looked familiar. Almost. That was the strange part. Galaxies are not always clean spirals. Some bend, some stretch, some tear themselves apart, or get torn apart by others. A number were gravitational lenses, massive galaxies bending light that was never their own. A lens can turn one distant galaxy into a curved smear of light, an arc, a ring, or broken fragments. To a human eye, that can look like noise. To the machine, it looked unusual. Others were collisions, 2 galaxies meeting badly. A collision can leave tails longer than the galaxies themselves. Gas clouds twisted, dust lanes torn apart, long tails stretched outward for millions of years. Then came stranger shapes, galaxies like jellyfish, losing their gas as they move through clusters. A jellyfish galaxy can look as if it is bleeding into space. Disks seen edge-on, flat, dark, almost like cosmic hamburgers. And some objects that fit nothing at all. Not lens, not merger, not normal galaxy. Just something odd, recorded, and waiting. In total, more than 1,300 flagged objects. More than 800 had never appeared in scientific literature. Not hidden, not invisible, just unpublished, unnoticed, unclaimed. Every one of them had been sitting in the Hubble archive already, in old observations, on old servers, behind ordinary file names. That is the first real twist of the story. The AI did not understand galaxies. It did not know wonder. It did something simpler. It compared images, millions of small sections, one after another, again and again. It was not looking for anything specific. It was looking for difference. Trained to ask one cold question: does this look unusual? Not impossible, not mysterious, just unusual. It scanned the full Hubble archive, almost 100 million cutouts, in 2.5 days. No fatigue, no boredom, no preference for famous images over ugly ones. It simply compared shapes, then marked the outliers. Then humans came back in. The AI did not finish the science. Astronomers still had to look, judge, classify, and ask why. The machine pointed. The people followed. Old images became new again. Stored data became evidence. Hubble had not changed. The universe had not changed. Only the method had. Hubble was only the beginning. New telescopes do not just observe, they survey, scanning, repeating, mapping the sky systematically. ESA's Euclid mission is mapping the dark structure of the universe. The Vera Rubin Observatory is beginning a 10-year scan of the southern sky. NASA's Roman Space Telescope will collect enormous wide-field images. Each one will produce more data than any team of humans can fully inspect. Night after night, year after year, billions of stars, billions of galaxies, billions of small changes. Somewhere inside that flood, there will be more objects like these. Not obvious, not bright enough for posters, easy to file away and forget. A discovery can exist before anyone discovers it. It can sit inside the data, pass every quality check, enter the archive, and remain invisible. Not physically invisible, just unnoticed. Hubble's archive was the first proof of that. It will not be the last.
The strange objects matter, but they are not the whole story. The real finding was smaller and larger at once. The data had been there all along. Hubble did not fail. Astronomers did not fail. Reality is simply larger than any single set of eyes looking at it, even after it has been photographed, stored, and reviewed. The universe was not hiding. The telescope was not blind. The data was not missing. We were. And somewhere, inside another archive, another discovery may already exist. Not waiting for a launch, not waiting for a miracle, waiting for someone or something to notice what humans missed. Subscribe, not for more noise, for a reason to look again.